Alright everyone, for this last experiment, you'll need a couple more things. So first, you'll need a balloon. Second, you'll want a container. And third, you need a water bottle and a straw. So what you're going to want to do is to have an adult take a scissors and poke a hole in your water bottle most of the way up. Then you're going to want to take your straw, poke it through down towards the bottom here, and once the straw's at the bottom, you'll want to glue or tape around the hole where the straw goes into the bottle. So I don't have any glue, so I just used tape, and as best I could to tape around this hole. This will prevent the air from escaping. And then once you get that installed, you'll want to fill your bottle up with water, but don't go past where the straw goes in. And ideally, if you have a straw that's bendable, that'd be even better. But I only have this one, so I'm using this one. So what we're going to do in this experiment is show how air and how pressurized air in a balloon can be used to do useful work on another thing. So in this case, we're going to use it to move some water around. So what you're going to do is put the water bottle inside of this bowl or container. This will prevent the water from spilling. And then next, what you're going to want to do is blow up the balloon, or have an adult blow up the balloon if you can't. And don't tie this balloon, actually. What you're going to do is just take it and twist it so that the air won't escape. And now make sure your water bottle is in here. It doesn't really have to sit straight. So with it twisted, what you're going to want to do is take the opening of your balloon and stretch it over the top of the water bottle. This might be a little difficult, so grab another set of hands to help you if you need it. So now we've got our balloon on top of the water bottle, and it's twisted. So now we're going to untwist the balloon. And as you can see, water starts flowing out of the water bottle and into the container. And it's actually slowly going to stop. And at this point, there's a lot of things happening here, and I'll go through them. So first thing I'm going to do is I'm just going to close off the balloon because the water has stopped, and we're not going to be able to force any more water out. So what happened here is a couple things. So when we had the balloon on top, we had a pressurized volume of air on top because the balloon is pressurized, and when we opened it, that pressure pushed down on the water level that was in here, and then that pushed and forced the water out and up through the straw out into the container. And so that happened because the pressure in the balloon was greater than the water pressure that opposed it in this column of water. And so eventually what happened is it stopped, and you noticed that. And so what happened then is due to two things. First is Boyle's law, and so that's the pressure times the volume is in state 1 is equal to the pressure times volume in state 2. And so in our initial state, we had our water level right below the hole in the straw, and we had the balloon on top, but it was still closed. It was not opened yet. And then what we did is we opened the balloon, and so what that did is now we took the air that was inside the balloon and forced it into the bottle here. And so now it was taking up from the water level to the top. There was the air from the balloon now had to take up that space plus the space in the balloon. And then as the water level kept dropping, it had to take up more and more space. So now all of this space inside the bottle had to be filled with the air that was all originally in the balloon. And so what happens is, due to Boyle's law, we had a certain pressure in the volume of the balloon, and now since we started increasing our volume, that means our pressure must decrease. And as our pressure decreases, we have less ability to then force the water out of the bottle through this straw, because we have less force pushing down on the top of the water that is able to push the water out. And so the second reason this relates is that as the water level is decreasing, you'll notice that now our water level is farther from the top of the straw here. So the pressure that is being exerted by the balloon has to push on this water, and it's going to push out water through this straw, but it has to push it against the force of gravity all the way up this straw until it can come out. And so what happens is you have something called hydrostatic pressure, which is the pressure due to a fluid usually referred to as water in a column. So this is similar to if you were to go scuba diving and you went down a lot of feet into the ocean, you would feel a lot of pressure on your body because the water above you is heavy. It's not weightless, it's heavy, and so it's pressing down on top of you. And the same thing applies here, although on a much smaller scale. So here we just have a straw that's maybe 6 inches long, but as we're pushing the water out of it, there's water from the top to the bottom of the straw here, and that little bit of water that's inside of this straw, that column of water has a certain amount of pressure at the bottom here. And so once the pressure force from the air in the balloon and the bottle is equal to the pressure force of the water in the straw, the flow is going to stop. And third, so my bottle wasn't completely sealed, so I probably could have gotten a little better, but a little more water out of the bottle here. However, it's sufficient as is. It doesn't need to be a perfect airtight seal, but that's kind of the third reason why this doesn't push out more water, is because then I have some of the pressure that's then escaping out of a hole in the bottle instead of doing useful work on the fluid, which is the water here. And so this has many practical applications, usually not in moving water, but sometimes. The most useful thing that pressurized air is typically used for is in an actuator or a piston, where instead of having, say, water that the pressure in this balloon is acting on, there would be a disc of metal, and that disc of metal would have a seal around the outside. And so when there is pressure acting along, say, the disc of metal here, what would happen is it would push that disc down, and that would either extend a rod or move some other fluid. This is how hydraulics work. This is how the brakes in your car work. This is how lots of things work in the world. And it's very applicable, and fluid systems, pressurized fluid systems, are really, really complicated and yet sometimes simple based on their governing principles.